Okay, rational functions, Unit 11, Day 3. So, a function in the form of p of x over q of x is a rational function where p of x and q of x are both polynomial functions. We've worked with rationals before, like you have x plus 4 over x minus 3. That's rational. If you have x squared plus 4x minus 1 over x squared plus 4, that's a rational. So you just have some function on top of another function. Okay? These are your steps. So first you simplify the function. So you factor it also. Factor it. Maybe write that next to there. So you factor the whole thing. And then you find the x-intercepts by setting the numerator equal to 0. And then you find the vertical asymptotes by setting the denominator equal to 0. And then the horizontal asymptotes, you find those using these rules down here. So if the degree of p is greater than the degree of q, so if the degree on top is greater than the degree on bottom, there's no horizontal asymptote. Okay? That's going to give you a slant asymptote, which is what we'll get into next time. Okay? If the degree of p is less than the degree of q, then the horizontal asymptote is y equals 0. And if the degree of p equals the degree of q, then y equals a over b, where a and b are the respective leading coefficients. Okay, so if you had like 2x minus 4 over x minus 1, that would be the leading coefficients there are 2 and 1, so that would be y equals 2 over 1, which is 2, so that's y equals 2. Okay, then for holes, this will be a coordinate point, and that's when you have factors that cancel. So here's how you find a hole. A hole is a point, xy, at which there's a break in the graph. A hole occurs when there is a common factor between the numerator and the denominator. So to find that, you set the common factor equal to 0, and that will give you the x-coordinate, and then you plug that into the simplified function to get the y-coordinate. Okay? Let's just get going on this. So we have f of x equals x minus 4 over x plus 4. The first thing we're going to do is simplify the function. Well, that's already simplified, so we're done with that. Okay, we're going to find the x-intercepts by setting the numerator equal to 0. So I'm going to have x minus 4 equals 0, which means x equals 4. So my x-intercept is 4, 0. And I'm just going to write that right there, and I'm going to graph that x-intercept. Okay. So that one's done. We have to find the vertical asymptote by setting the denominator equal to 0. So that's x plus 4 equals 0, which means x equals negative 4. So my vertical asymptote is x equals negative 4. So I'm going to go to negative 4, and I'm going to draw that vertical asymptote right there. Now, to find the horizontal asymptote, the degree of p is greater than the degree of q. That is not true, so we're not going to use that one. The degree of p is less than the degree of q. Also not true. The degree of p equals the degree of q. That is true. So this is going to be y equals a over b, where a and b are the leading coefficients. My leading coefficients, x minus 4, the leading coefficient is 1. X plus 4, the leading coefficient is also 1. So that's going to be y equals 1 over 1, which is just 1. So I'm going to go up to 1 on my graph. Yeah, so my horizontal asymptote is y equals 1. Then go up to 1 and draw that asymptote right there. Okay. Now there's no holes because nothing canceled at the beginning. Now I can draw this. So the way you draw this is you look and see what points do I have on here. Well, I have that point of 4, 0 for my x-intercept. So I know that this graph is going to go, it has to cross through that point right there. And the graphs always just go right along the asymptotes. So that part of the graph is going to go that way along the asymptote. And then you always do the other graph in the opposite corner. So you go kitty corner, and that's going to be the other part of the graph. Okay. Now my domain, that's your x values. That's your x values. So that's going to be negative infinity to negative 4, and then 4 to infinity. My range is the y values, so that's negative infinity to 1, and then 1 to infinity. Okay? Let's do another one. So we have 2x minus 6 over x minus 1. First thing, we have to simplify the function. So I'm going to factor out that 2 on top. So you get 2 and then x minus 3 over x minus 1. And that's simplified. Find the x-intercept, so I assign the numerator equal to 0. So we have 2x minus 3 equals 0, which is x minus 3 equals 0. So x equals 3. And that x-intercept is 3, 0. Always write that as a coordinate pair. Okay. Now we can find the vertical asymptote by setting the denominator equal to 0. So we have x minus 1 equals 0, which means x equals 1. So the vertical asymptote is x equals 1. And I'm going to go to 1, and I'm going to draw that asymptote. Now the horizontal asymptote, the degree of p is not greater than the degree of q, so that's not 1. The degree of p is less than the degree of q, also not 1. The degree of p equals the degree of q, true. So I have to do my leading coefficients. The leading coefficient on top is 2. The leading coefficient on bottom is 1. So that's going to be y equals 2 over 1, which is y equals 2. So my horizontal asymptote is y equals 2. Then we're going to draw that right there. Holes, there's no holes because nothing canceled at the beginning. And then you just look and see what point do I have. We have that x-intercept right there. So that's going to be that side of the graph, and that's the other side of the graph. Okay, now my domain, negative infinity to 1, then 1 to infinity. My range, negative infinity to 2, and then 2 to infinity. Okay, now let's do this one. So first, simplify the function. So x squared minus 1 factors to x minus 1, x plus 1. Then the x minus 1 stays on bottom. Now those cancel, and you're left with just x plus 1. So really, this is just going to be a line. We don't have to go through all of these steps now because we just have x plus 1. We are going to have a hole though. But let's still just go through these steps. So we simplified the function. We need to find the x-intercept. Oh, just kidding. We're not going through the steps. Okay, so like I was saying before, this is just a line. So we're just going to graph this as a line. But we are going to have a hole because the x minus 1 canceled. So we're going to set the x minus 1 equal to 0. And you get x equals 1. So at that point, my x point is 1. Now I'm going to plug that into the simplified equation. I get f of 1 equals 1 plus 1, which is 2. So my hole is at 1, 2. And then we can just draw that hole right there. And then we can graph this from the y equals mx plus b, where m is the slope and b is the y-intercept. So my y-intercept is 1, and my slope is 1. So there's my y-intercept. Then I go up 1 over 1, up 1 over 1, up 1 over 1, and this is just going to be a line. Okay? So my domain is negative infinity to 1, and then 1 to infinity because there's a hole at 1. The range is negative infinity to 2, and then 2 to infinity because there's a hole there. The x-intercept is 0, 1. Vertical asymptote, there isn't one. Horizontal asymptote, there isn't one. Okay? Let's do this one. So we have f of x equals x plus 5 over x squared plus 9x plus 20. First, we have to simplify it. So that's going to be x plus 5 over x plus 5, x plus 4. Those x plus 5's cancel, and you just get 1 over x plus 4. Now my x-intercept, if you set the numerator equal to 0, 1 never equals 0, so there is no x-intercept. Vertical asymptote, we have x plus 4 equals 0. Subtract the 4 over, so you get x equals negative 4. There's my vertical asymptote, and I'm going to draw that right there. Horizontal asymptote, the degree on top is less than the degree on bottom, so that's going to be a horizontal asymptote of y equals 0. Okay, then we do have a hole on this one, so the factor that canceled out is x plus 5. So you're going to set x plus 5 equal to 0, then subtract that 5 over, so you get x equals negative 5. Now plug that into the simplified equation. So that's 1 over negative 5 plus 4. which is 1 over negative 1, which is negative 1. So my point is negative 5, negative 1. That's where my hole is. So I'm going to go to negative 5, negative 1, draw that hole there. Now, we don't have an x-intercept. We don't really have any points on this, but we do have the hole, and the graph has to go through the hole. So the left side of the graph is going to be right there, and then the right side's up there. Okay, the domain, negative infinity to negative 5, then negative 5 to negative 4, and negative 4 to infinity. Range, negative infinity to negative 1, then negative 1 to 0, and then 0 to infinity. Okay, we're going to save those last two. Remember to take the quiz, and I'll see you guys when I see you.